Okay, so now we are looking if a car travels around a 2 kilometer track in 4 hours. So if we draw our picture for this, so if we start here, and since it says we're going around, that means it's going to be a circular track. So we're going around, and this is 2 kilometers in 4 hours. So the first thing we need to do is we need to look at speed. If you remember, speed equals distance over time. And if you remember, you guys do need to write the formulas out every single time. So when we look at this, our distance that we have traveled is going to be the 2 kilometers. So we have 2 over our time, which is going to be 4 hours. And when you look at this, when you take 2 divided by 4, you're going to get a half, which is 0.5. Then when you go to look at your units, our unit for distance is kilometer, and our unit for time is going to be hour. So our unit for speed is going to be km over an hour. Okay, so when we look at velocity, so velocity is displacement over time. And when we look at our picture, so we're going around a track and coming back to the same point. So since we're starting and stopping in the same spot, our displacement is going to be 0 because you start and stop in the same place. So there's that. And then the time that it takes, so it takes us 4 hours to go around our track. So if you remember from math class, 0 divided by anything is going to equal 0. And our speed is still going to be in kilometers per hour. If you remember, we do need a direction with velocity. But since our velocity is 0, we do not need a direction with it because it's not... We're not moving in any direction with this. Well, that's how you would set up a problem like that. So if we look at our distance time graph on the next page, so we have 4 different points that we are going to look at. We're going to look at point A, or line A, B, C, and D. So when we're looking at slope in math class, it is rise over run. Rise over run. And when we're looking at this, remember this is our y-axis. This is our x-axis. So our y-axis is going to be our rise. So the rise is on the y-axis. The run is on the x-axis. And so that means as we're looking at this, your slope equals, if we look at what our rise is, our y is our distance. So that means it's going to be distance. And when we look at what our run is going to be time. So it's going to be distance over time. And what we have just learned is that distance over time then would be our speed. So that means the slope of this line is going to tell us what our speed is at these different intervals. Okay. So when we're looking at this, so like at part B, since we are holding still, our distance isn't changing. At this point, we're starting at 40 and we're ending at 40. Our speed is going to be 0 because our slope is also 0. It's completely flat. So something that is flat has a slope of 0. And then as it increases, as this end goes up, it's going to get bigger and bigger and bigger. So that means this line here, A, is going to have the greatest speed to it. And then if you ignore B, D is going to be when you're traveling the slowest and you're still moving. All right, so let's look at how to calculate some of these. So if we're looking at the instantaneous speed at point A, so we're just looking at this segment right here. So we're figuring out the speed at any given point. So at any point along this line, we can figure out what their speed is going to be. So what we're going to do, so speed equals distance over time. Our distance that we travel, so we're going to look at this point. I'll mark it in red here. So at that point, we have already traveled. You go over and look at the distance. We've traveled 40. And we've done this in 10 minutes. So when you do the math for this, 40 divided by 10 is going to be 4. Then when you look at your units, our units for distance is meter. And our unit for time is minutes. So our instantaneous speed at any given time along that 0 time till 10 minutes into the drive, it's going to be 4 meters per minute. All right, looking at the next one. So if we're looking at point C, again, speed equals distance over time. And yes, you need to write this over and over and over again. It'll help you remember what your formulas are. Okay, so this is going to get a little trickier because we're looking at the speed already into the drive. So we're looking at this point to this point. So when we're looking at our total distance, if you look, we go across, our starting distance is we're starting at 40 and we are ending at 60 as we look across. So what you're going to do is you're going to subtract those two numbers away from them. So if you're starting at 40 and you move to 60, that is going to be 20 meters. And then when you look at how long it took, we're starting at time 15. We are ending at 25. So that is a 10-minute time frame. And 20 divided by 10 is going to be 2 meters per minute. Let's also look at the instantaneous speed for point D. So we're looking here. So from this point to this point. So again, speed equals distance over time. Our starting distance, again, is going to be now the 60 here. But now our line stops, and I'll erase it so it makes it a little easier to see. Our line stops right in between 60 and 70. So we can call that 65 because it's pretty much right in the middle. That's what we'll estimate it at. So that means our total distance is 65 minus 60. So that's going to be 5. And when you look down below here with this one, we're going from 65 to, going from 25 to 30. That's another 5 minutes. So that means our speed for this one is 1 meter per minute. For average speed. So average speed we will do in the next video.